There it goes. Hey, well, welcome everybody once again to Astronomy Daily Live. Hope everybody's doing well. It's 2 hours UTC on this is the 6th of February, 2019. It's, yeah, wow, we're almost already a week into the month already. That's pretty amazing. So hope everybody's doing well. Hey there, Andy. Nice to see you in the chat. Ingrid, I'm not quite sure if you're there, but you popped in a little bit early and said hello. So I'm saying hello as well. So yeah, so hope everybody's doing well out there in the universe and in the world. Yeah, everything is good here. Still cloudy a little bit. Might be getting a little bit of rain, maybe a little bit of SNOW. But we don't talk about those things or think about those things here because they just don't exist, right? They're just not there. So, yeah, all right, well, cool. Well, so I hope everybody's doing well. So grab your favorite consumable and let's sit back for the next hour-ish or so and think and talk astronomy and space and science and all kinds of nerdy things. So cheers. My new tune got some attention on TKF Arts. Oh, okay, cool. I greatly appreciate the forwarding of that. So yeah, that was just a little messing around I was doing over the weekend. Nothing, you know. I actually find that some of the good stuff is things that you don't really work hard on or think about too much, right? So yeah, that I'm actually collaborating with another YouTuber. She wants kind of nice meditative sounds, and so we're beginning a collaboration. And so yeah, I'm trying to think about what kinds of sounds she might like, and she hasn't given a lot of feedback yet. So it's like, okay, I'm just going to do something here, and actually created a few different songs over the weekend, and as with most creative things, probably a good 90% of it is garbage, just absolute junk, right? But once in a while, you'll find a little bit of jewels there, and that one I posted was at least in my opinion, just sort of like, I'm at least willing to put it out and let folks listen to it. But yeah, most of the creative things that at least I do, they sort of have to pass through my filter, and I'm a pretty harsh judge, so I should probably put out a lot more, because I shouldn't necessarily judge my own things. Because, being a musician and all that, you hear all your mistakes and all your flaws, and it's like, oh, I should have done that, and oh, I missed that, and just on and on and on and on, right? Thinking way too much about it. But yeah, well, cool. That is extremely cool. I look forward to whatever happens, right? So, all right, well, I want to say hi to ERRT Radio. Johnny is in the house as well. Very cool. Nice to see you all there. And on the panel, once again, from fog-ridden Louisiana, is Bobby. Hey, what's going on?
Hey, I think you for sure be saying that because I'm definitely going to be in it tomorrow for the doctor's appointment.
Wow. Okay. Yeah. Well, be careful. Be careful. I living in the desert here, I don't have a lot of fog, right? But when we do, it's like, I'm not going anywhere because people, I'm not so worried about myself, right? Driving through fog, right? I'm not going to try to pass anybody. I'm going to have my lights on. I'm going to be, um, very aware. But people here aren't used to driving in the fog, and so they may not even think about. It's like, oh, this person who's driving in front of me is driving way too slow, so I'm going to zip around him, right? And whammo. So yeah, I try to avoid that when I can. But I I would
I was
think
telling
we're
you, I was one time a person and he was just playing with his girlfriend.
uh yeah. Hey Bobby, your connection is a little funky. You're sort of robot Bobby over there. So I don't know if you've
My
got I don't know if you've got other things going on, either in terms of bandwidth or things on your machine. But yeah, I'm at least hearing only about half of what you're saying. So just FYI. Anyway, also on the panel, once again, is Tom. Hey, what's going on over there?
Hey, Cosmic. Hi, everybody. Hope you're all doing well. Not too much going on, but we do have an event on this day in space. Back in 1971, the Apollo 14 lunar module landed on the moon with Alan Shepard and Edgar Mitchell on board. They spent 33 and a half hours on the moon, and in that time they collected about 95 pounds of moon rocks to be brought back, and Alan Shepard hit a couple of golf balls with a makeshift club he somehow got onto the ship.
That's great. That's so awesome. Now that was sort of a return to flight, right? Because 13, had that little mishap, right? So
yeah, they had made some changes to the way they did the oxygen tanks storage and all that, so they wouldn't have a repeat of that event.
Yeah. Wow.
Yeah, I think this one was delayed for a few months from their original plans, 4 months or something like that.
Right. Well, that's not too bad. Yeah. That's not bad.
Okay.
Yeah. So that.
Yeah, it was. Let's try it again one more time about driving in the fog. But how about you? Like one time when about when somebody was driving slowly because they were playing with their girlfriend, and I was like that really made me mad.
Yeah. Well, that story, Bobby, was loud and clear. Perfect. So.
Okay, so thank God I didn't need to reboot my router yet because what happening I was on my tune in on the ambient radio station.
Ah, gotcha. Yeah, bandwidth. Yeah. So yeah. So they were on the moon for 33 total hours, and that was in 19. What year was that?
71.
71. Okay. So there was Apollo 11 in 69, and then Apollo 12. Was that in 69 as well, or did they move? was that in 70? I'm not exactly sure. 13. Yeah, 13 was, I think 13 was in 1970 then, right?
12 launched in 69.
69. Oh, okay. Okay, cool. Cool. So 13 was in 1970. 14 was in early 71. So cool. Very nice. Very nice. I just, I mean, I'm trying to imagine, that whole journey, right? It's I mean, I, 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 I think, everything was probably really, really planned down, moment to moment. But I think, they did have, some free time, I would hope. Although, they were probably making observations and conducting experiments and everything, the whole way up and the whole way down. But I hope that they had, some time to sit back and sort of, regard their situation. This was Edgar Mitchell. Is that right? And
yeah.
Shepard. Yeah.
Shepard and Mitchell, right?
Yeah. Mitchell, right? When he came back, he actually started the Noetic Institute, where so he was very, very affected by his trip to the moon. He went really, really, really deep. I mean, he realized what an amazing situation he was in, and he got that overview effect, right? So he was greatly affected by that. He actually wrote a book, which I think I actually have on my Kindle, and read, wow, quite a few years ago now. I wonder if I can find the title to that book, because I want to recommend it, is what I want to do. I'm pretty sure it was him that wrote it. Edgar Mitchell. Books. I think if I see it, I will recognize it. Oh, maybe not. The Way of the Explorer. Yeah, I guess maybe I'm not going to recognize it. Let's see. So I guess that must be what it was, because I guess he only wrote 3 books. He wrote Psychic Exploration in 1974, and then in 1996 he wrote The Way of the Explorer, and then in 2014 he wrote Earthrise. And I don't think it was Earthrise that I read. I'm pretty sure it was The Way of the Explorer. But yeah, he was very much very affected by that. There was another astronaut too. I forget his. He was Apollo 15 or 16 or 17. He came back and became a artist, a painter. I forget who that was. I think he just recently passed as well. But yeah, I don't remember exactly who that was. There are so many things that I either don't know or don't remember. But yeah, wow, yeah. But yeah, I just try to imagine that journey, because that's a journey that I would like to take. I think that a 7-day cruise to the moon and back would I I think a lot of people would do that, right? And if Elon Musk, if his promise of like $100 a pound is realized, right? Then you know that actually makes it, you know, moderately affordable for a lot of people, right? You know, for the price of a car, right? A moderately expensive car, you could have a 7-day cruise, sort of the Apollo 8 style, right? So um, um, what I sort of see, right, is that day one is launch day, right? And you launch and you go into orbit around the Earth, and you orbit the Earth for maybe a couple of days, right? Because I mean, everybody wants to see that, right? So, you know, orbit the Earth a couple of days, and on day either 2 or 3, right? You fire your rockets, right, at the right time and the right place, and you shoot yourself out towards the moon, right? And then you have a couple of days of cruising to the moon, right? And then on day 4 or so, you whip around the moon, right? I mean, it only takes a couple hours, you know, to whip around the moon, and you're going to get really, really, really close. I think Apollo 8, don't quote me on this, but was something like 50 miles above the moon. Something, I mean, really, really close, right? So you know, almost scary close, right? So you know, you whip around the moon, you lose radio contact with Earth for I don't know how long that is. It's not incredibly long, but maybe, you know, there's some kind of a relay satellite in a polar orbit. So, you know, you never really lose contact, right? You just have to communicate with the relay satellite instead. But, you know, whip around the moon, and then come back, and that takes a couple of days, right? And then you go around the Earth a couple more days, and then you land, right? It's a 7-day cruise to the moon and back. And I mean, if that were available, right, I think that lots of people would do that. And, you know, I mean, you know, do it like most people buy cars, right? You get a loan, right? I'm sure banks would absolutely love that, right? So get yourself a loan. It's $100 a pound, right? So you know, typical person was what, 150 or so, and then, you know, with luggage, you know, maybe 200 pounds, right? So for $20,000, right, you could have a 7-day cruise to the moon. And I mean, now that really isn't reachable by a lot of people, but you know, that's in sort of the realm of possibility, right? And those are sort of the numbers that Musk is talking about, right? In terms of being able to reuse these rockets and stuff.
Hey!
It's like, hey, you're back.
Yeah. I had to now just reboot the router, but I also got to update the firmware.
Mm. Well, I'm glad you were able to come back. I noticed that you left, and it's like, huh, he's having to reboot something. So cool. Well, I'm gonna check on the chat here a little bit.
Alan Bean was the astronaut you were thinking of, I believe.
Ah, yes.
He became an artist, or he was an artist, I guess, but he did some more art when he got back. And he passed away in May last year.
Yes, that's right. That's right. Yeah. So I mean, look, I don't think that you can go out there and do what those folks did and not be affected, right? I mean, you have to be changed in some way. Even if you're, by the book, just following the program as if this is a simulation, there's something twittering in the back of your head when you are looking at that Earth, right, from 1/4 of a million miles away, and it's 16 times the size of the full moon, right? And I think that you might be able to see lights and stuff. I'm not exactly sure. It sort of depends on the phase, right? But yeah, I mean that would definitely have a very strong effect on lots and lots of people. So hey there, 9-inch Colas, nice to see ya. How's it going? Hope everything's well. Cheers. Oh, cool. So they did they walk out of the lander like right away, or did they hang out there? When did they pop out?
I don't know exactly. Yeah, just looking at the Wikipedia, it doesn't really say.
Yeah, I mean, it must have been at least a couple hours, right? I mean, I would think, right? They got to make sure everything is secure. Things are turned off. You got to make sure the ladder is down, right? All of that. So
right.
I'm sure. Yeah, I'm sure there was a procedure, right? But yeah, that's quite an amazing thing. Now, I don't really have personally. I don't have any real interest on walking on the moon or walking on Mars or anything like that. I don't think that. I mean, for me, I don't really think that is necessary, right? I would just like to go there and see it up close and look back at the Earth and just be completely blown away. Hey there, Mr. Tim, what's going on? Thumbs up from Mr. Tim. Cheers. Hope everything's well over there in the UK. It's 2:24 over there in the UK. So Tim is up late again, but joining us. I think that's just absolutely fantastic. So yeah, Tim, we were just talking about the fact that today in 1971, the Apollo 14 lander landed on the moon. So yeah, quite an extraordinary thing. There's a lot of debate about why no one has gone back, right? And yeah, I mean, there has to be a motivation, right? There has to be a reason, and the reason for going there at that time was, you know, one to do it, right? Because, you know, this has been a thing, you know, that we've wanted to do for thousands and thousands of years, right? But two, of course, you know, the motivation was, you know, to beat everybody else, right? So I'll be the first one.
What's
So
up, Tim? How you been doing?
Oh, not too shabby, thanks. Just been busy painting and doing certain jobs roundabout here and there and everywhere. Trying to keep the missus happy too.
That sounds like one of those four-letter words, though. W-O-R-K. I don't know if I approve of that.
Hence the paint-covered top.
All right. Well, you know, you have to practice.
Yeah, on my top.
That always happens. Do you, Tim, over in the UK, do you have like a hardware store like Ace Hardware or Lowe's, or
Yeah,
what
we
do you
have a
call
few
them?
different ones.
What do you call them over there?
I usually just do the cheap places, but you've got like, what the hell they're called? I don't use them because they're so expensive, but we have like Wix and B&Q. Those are usually big hardware stores, anything from doing your gardens to doing your home.
Yeah, cool.
Sheds and that sort of thing.
Yeah, neat. So yeah, but you know, I mean, and they have everything, right? They got, yeah, I mean, all the plumbing and all the screws and nails and wood and all that, right?
A to Z.
Yeah, very cool.
Oh, A to Z.
Tim, is Tesco is like the Walmart but in the UK?
Tesco, we just regard it as actually it's or it was the top supermarket in Britain. So I don't really know
what's the number one now.
I believe it's still Tesco.
Cool.
As far as size and profits, but there are some German ones, and they're starting to do really well because they're bargain supermarkets, Aldi and Lidl.
Interesting. Yeah, I always like to. Yeah, I always like to hear about different places that I will probably never ever get to. So you know, I like to hear about these things because they're different, right? You know, I mean, it's the same, right? You've got wood and screws and pipes and all that, and we do too. But yeah, you know, it's a different named stores, and you know, the experience is probably slightly different. So cool. All right. Well, I thought what I would do, I'm going to check the chat again really quick. James Dugan, hey, nice to see you in the chat. James and I, we seem to see each other all over the place. So cool. We just seem to subscribe to the same channels. So yeah.
Actually,
nice
I think I just saw James in a live stream by Bill NY. I said I was going to bed, and then I saw your pop up, and I thought, bugger it, I'll call in and say hello.
There you go. Uh-oh. I was messing around with this little thingy here, and I just destroyed it. I'll have to mess with it later. All right. Quit fiddling around, Cosmic, and get going here. All right, cool. So I thought what I would do, you know, one of the things that I like to do every day, if I can, and I certainly have not, is go over to archive.org. That's arxiv.org.
The Internet Time Machine.
Yeah, well, no, that is archive, ARCHIVE. I'm talking about ARXIV, which is it's a huge repository for new sort of bleeding edge scientific and mathematical papers. And new papers are coming out every single weekday, right? It's run by Cornell University, and each day hundreds and hundreds of new papers, right? In all kinds of topics, including astronomy, of course. So what I like to do as often as I possibly can is go over there and just sort of look and see what the latest and greatest published, at least the accepted for publication papers are, because that's a great way to keep up with sort of the new things, and every single one of these papers is sort of like a launching pad, right, into at least dozens of different topics, right? I mean, you go through a paper and, they start talking about something and it's like, what is that, right? And so you go off that way, right? It's sort of like a branch thing, right? It's, and so, the journey through a paper can literally last hours and hours and hours, or days and days and days, right? And then on top of that, right, you can also look at the references, right? And each of the reference is sort of like a history lesson in that topic, right? So yeah, I mean, these are just really, really, really great ways of sort of diving into, whatever subject you want, and I found, at least, that it doesn't really matter what paper you choose, right? Because at some point you're going to run into some list of topics, and then each one of those is going to have a list of topics, and then each one of those is going to have a list, and it just it's just this explosive things, right? So what I do, right, is I go over to the astronomy lists, and in fact, let's do that now. I'm going to share my screen when I can. There we go. The old potato here is running a little bit slow. Going to infinity. We're all going to infinity. Look at that. Woohoo! There we go. All right, let's go over there. I'm going to do that, and then I'm going to go over to here, and then I'm going to go here. So here's, hello there. Whoop, I've got a kitty on the lap. Things are good. Hello there. Hello. All right, so here is the main archive.org list, and yeah, there's all kinds of physics, math, computer science, biology, finance, stats, electrical engineering, economics, right? All the latest and greatest so-called bleeding edge stuff. Hello. Kitty wants attention here, but you ain't gonna get it because I'm looking at the archive So let's go into the new stuff. Like I said, they update this every weekday, and it's usually around like one hour UTC or so. Sometimes it's a little bit later, sometimes it's a little bit earlier, but usually by 1 or 2 UTC, they'll have the current day's list. So if you go to new, right, then we will see that yes, indeed, they've got them for Wednesday, the 6th of February, 2019. And so what I like to do is I just sort of look at the titles, right? And of course, here they are. This also lists the abstracts as well, which is sort of like like an executive summary, right, of the entire thing. It's just a very, very brief and quick synopsis of the entire paper, right? So if I find a title that is sort of like, okay, that sounds interesting, then I'll read the abstract. And if the abstract is sort of enticing, then I'll go into the paper itself, right? So that is exactly what I'm going to do here. So let's just see. AGN all the way down. So AGN is active galactic nuclei. So of course those are the centers of galaxies that are active because of lots of reasons. I don't really know if we have a really good understanding of why, but we certainly can see them being active, right? They're changing in brightness or whatever else, right? Let's keep going here though. Binary radio velocity measurements on the Kelvin-Helmholtz instability. So that's kind of an interesting topic, which I have to remind myself exactly what that is. But that's sort of an older concept that you learn in school and then sort of promptly forget. So let's see. So discovery of tidal tails in disrupting open clusters. Oh, okay. That's kind of interesting. So tidal structures in star cluster Coma Berenices. So yeah, there is a Coma star cluster, which you can actually see with the naked eye. Of course, you have to know exactly where to look. And it's kind of faint, right? You have to be out where it's pretty dark, but it's pretty big. It's probably about as big as the Hyades in terms of the apparent size, but I think it's much further away. But yeah, well, this is saying 85 parsecs, so that's actually pretty close. So yeah, I don't know, but I guess again, Gaia is showing that I guess they're seeing some kind of tidal disruptions with these things. So that's pretty cool. So let's see. It looks like they've identified cluster members and given it a mass here, 112 solar masses. So, there aren't going to be 112 stars, right? Because some of the stars are going to be big, some of them are going to be small. So there's going to be a distribution of actual masses. But if you add it all up, that's sort of what they're getting there. Tidal radius of 6.9 parsecs. Okay. Well, kind of interesting. Let's keep going here a little bit. Let's see. I have absolutely no idea what Jordan Bronsdicke theory is. That seems a little bit interesting, I guess, if you're into those kinds of things. Metallicity calibrations. Now, astronomers, they consider anything that isn't hydrogen and helium a metal, and you sort of put that in quotes. So when you see metallicity, what you commonly think is like, okay, iron and copper and gold and silver and all that. And now, to an astronomer, carbon is a metal, oxygen is a metal. No, it's just terminology, though, right? But that's these astronomers, they're a little goofy sometimes. So and this is just another example of that, right? So yeah, if it isn't hydrogen or helium, it's a metal. So yeah, whatever.
And they consider all those. They consider all those metals to be contaminants.
Contaminants, yes, yes. And actually, if you agree with the whole idea of fusion, right? Then the amounts of metals inside of stars or inside of galaxies is kind of an indication of age, right? Sort of an indication of age and or sort of where they are along their lives, right? So, all right, let's keep going here. Physical nature of neutral hydrogen intensity structure. Not quite sure what that is. So, carbon monoxide emission lines in quasars that have a Z of approximately 6. Now, that's a redshift of 6, which again, if you sort of agree with that theory, that is very, very, very far away. I'd have to look at the math, to determine that exactly, but that's like extremely far away. And I think carbon monoxide.
Hey, you forgot about me, Johnny Unitas.
How can you forget about Bobby? Impossible. Anyway, carbon monoxide can be seen in the submillimeter and millimeter wavelength range. So it's kind of interesting, though, right, that an object that far away, we're seeing, carbon and oxygen in, what should be relatively young objects. So, because they're so far away, we're seeing them as they were, billions of years ago. But, we're seeing carbon and oxygen in those too. So that's kind of neat. Let's see, multiple stellar populations in the inner parts of NGC 24 globular cluster. So, well, that's kind of interesting, right? Clusters of stars are at least thought thought to be, have formed about the same time. Even the globulars, the globulars sort of, I think, the theory goes is that, they sort of have a different path. They sort of formed when the galaxy formed. At least that's the theory. But yeah, so, the fact that they're seeing, lots of different populations of stars in that globular is kind of interesting, I guess. Whoop, I don't know what I did there. I must have clicked on one of the authors. So yeah, see, each one of these authors is a link, right? So yeah, let me take this opportunity, right? So if you click on an author, you'll get a listing of all the papers, that they were either the author of or the co-author of, right? So here is J.P. Brodie. I think that's what we searched for here, right? So there's one. So yeah, this is kind of an interesting way to sort of see. It's like, okay, well, what is this person working on, right? What is their field of interest, right? And just sort of looking here, right? Globular cluster. Yeah, it's hard to know if J.P. Brodie and Jean P. Brodie are the same person. Could be, doesn't necessarily have to be. Let's see, J.P. Brodie. Here's another one, but there's a glob there. So maybe this person is sort of interested in clusters. Maybe. Yep, there's another globular. Looks like this person's a co-author in a lot of papers. Early type galaxies, globular again. Anyway, so yeah, there again is a path for you to take that is kind of interesting, right? Let's see. So yeah, so this is actually using the HST to look at the populations of that, and that's a good way of doing it. The HST has a bunch of different filters, so you can look at the colors and look at the differences in the colors and all of that. Kind of cool.
It's the anybody that's on KTRA, is the web stream down or something? Because I was trying to get it on my Fire Stick and it wasn't letting me go.
Not letting you do it, huh?
No.
Well, they might be down at the source. I don't know.
I got another browser I can try.
Go for it. Joule-Simpson's paradox in galactic archaeology arises when a trend appears in different subsets of data but disappears or reverses when these subsets are combined. 7 cases of this phenomena for kinematical relations believed to constrain the Milky Way disk formation and evolution. That's kind of strange, right? Where you see a trend in a subset, but when you combine a bunch of subsets, that trend either vanishes or reverses. Huh? Never heard of that before. That's yeah. And they I guess have some examples of that here. Kind of neat. I'm not exactly sure what chemotaxis kinematical relations are. Something
Well,
to
I
do
think
with.
if anybody can hear that right now.
I can hear something very, very faintly.
Okay.
Moderately
Yeah,
faintly,
it
at
was
least.
the browser. I changed browser and it's working.
Cool. Cool. So a large catalog of accurate distances to the local molecular clouds, the Gaia Data Release 2 edition. Sweet. So they've apparently accurately measured. I don't know why that happened. Accurately measured the distances to some local molecular clouds. Huh. I wonder. Let's dive into that a little bit. Maybe you can turn that down a little bit, Bobby, if you don't
Or I
mind.
can just cut it off for sure.
Well, if you don't mind, a little bit. I know that you like to multitask, so yeah. Don't want to interfere with your multitasking there if I don't have to. So this is slowly loading. It's either because my bandwidth is really slow or it's a big paper. It's probably a combination of both. We're going to find out. 28 pages. That's not too bad. That's pretty big. Pretty big. I'm kind of interested in knowing what they consider local molecular clouds. So let's see, and yeah, I'm thinking about it a little bit more, and it's like, wow, I mean, it's hard enough, to get a distance to a star, right? But they're trying to get a distance to some kind of an amorphous blob of stuff. So that's pretty amazing, pretty amazing. But I'm kind of interested in just sort of seeing what they consider to be. So okay, so they're taking data from a bunch of different sources, including pan stars. Yay, that's good. NOAO source catalog, 2MASS, and Gaia. Sweet, 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 sweet. Okay, so let's see here. Assembly of the final catalog. Okay, so they're cross-matching them all, right? To confirm, right, that actually is an object and that's where it is. That's important. Let's see. Okay, here's some pictures. Let's see what this is here. So set of 2D distance extinction stellar posteriors towards the Perseus molecular cloud. Ooh, yeah, huh. Incorporating parallax measurements. So the most probable distance and extinction to each star is marked with a red cross. So, okay, it's sort of like where these things are mostly concentrated. And I'm not quite sure what we're seeing here. This is... I'm not quite sure what, in this case, this is the Greek letter mu, right? And it's in magnitudes, but I'm not quite sure what mu is, and I'm not quite sure what A of V is either. But okay, probably be able to find out in the actual text. let's see if we just do a quick search for the word figure and see if. So the Gaia 2 astrometric data has 2 significant effects on our stellar posteriors. Illustrated in figure 1, which shows a set of stellar distance extinction. So one of these is distance and one of them is extinction. Okay. Not quite sure how to interpret that. But clearly the little red crosses are where the concentration there is sort of the highest. So yeah. I'd have to dive into the paper a lot more to really know what's going on there. So yeah, just talking about their methodology. Of course, they like to use all kinds of mathematics and stuff. It's really not all that hard. It's just, symbols, and of course you have to understand what the symbols mean, right? So that's where it starts to get a little tricky. Distance modulus and cumulative A of V. Again, I'm not quite sure. Mean extinction profile. Wow, they've done quite an interesting analysis here for sure. Wow. Always amazing how much work goes into these things. So of course they throw it into a model. Makes sense. So here's a list of what they're calling local molecular clouds. This is really all I was really interested in, was just sort of seeing what they consider local. And here's a distance in parsecs. So, okay. Molecular clouds in Aquila, Canis Major. Here's the California Nebula, I guess. Not quite sure what CAM is. There's a constellation, Camelopardalis. I'm not quite sure if that's it. Cepheus far, Cepheus near. Zoom in a little bit here for you. Chameleon, that's of course a constellation too. Corona Australis. Crossbones. I don't think I've ever heard of that one. Gemini OB1. Hercules, Lacerta. Okay. Here's a couple in Orion. Ophiuchus. Here's the Rosette Nebula, I assume. Didn't know that there were any molecular clouds in Ursa Major. Huh. That, of course, is commonly called the Big Dipper. Yeah, I didn't realize that there were any molecular clouds up there, but at least according to these guys, there are. Now, this is kind of an interesting thing here. See how it's saying 133 plus or minus 2 plus or minus 7? What is that? Usually you just have one of these, right? These are called the uncertainty or the error bars, right? But for some reason it's plus or minus 2 plus or minus 7. I don't know what that.
That's the variance of accuracy, isn't it?
I don't know. Let's see. Average distance to 20. In 1, we list the name of the cloud. In 2 to 5, we list the longitude and latitude bounds. In 6, we list the some kind of a threshold. In 7, we list the average distance we compute for the cloud given these set of pixels. The first error term is the statistical uncertainty, and the second error term is the systematic uncertainty. Yeah. Okay. I guess we definitely have to dive into the paper to know what the differences is between this error term and this error term. It sort of looks like the systematic one is significantly larger, right?
There's a big variance between the two.
Yeah. So section 4.3, we can actually go to section 4.3 and see if that makes any sense whatsoever. 4.3, let's see. Lots of nice little plots here. I always like to see those.
Bloody notification problems. Oh, sorry.
4.3. Average cloud distances and uncertainties. Noisy distance. All right, well, regardless, it's pretty cool.
Is one a calculated inaccuracy and the other one an observed?
Yeah, we'd really have to dive into the paper to really get a good idea as to what those are. But they, at least as the title implies, they seem pretty confident, right? So anyway, here are the numbers at least. So yeah. And of course, these are parsecs, right? And one parsec is like 3.26 light years. So in order to change these to light years, you have to multiply that by that. So some of these are pretty far away. Kind of cool, though. It's nice, that they're using a bunch of different surveys to come to these kinds of conclusions. But yeah, this is flying a little too high over my head for sure. Here's sort of the locations of all of them.
In that case, I have no chance.
Well, most of these papers are going to be like that, right? For me, it's sort of an exercise, to sort of stretch a little bit, and I mean, I'm trying to do it live here, so I mean, it's not exactly fair, right? I mean, one would have to sit down with this for a very, very long period of time to really get an understanding. Really, honestly, right? The only people who really understand all of this are the people who wrote it. and so
so it's like an exercise in trying to understand something a little different, pull a little meaning out of it.
Trying, yeah. But when it flies over your head so high, that you can't even reach, it's like, oh, yeah.
But the exercise is good.
It's good to stretch, from time to time. I think so. Yeah. So, but cool. It's it's kind of neat that they've you know, done this pretty amazing work, pulled, you know, from different sources, and compiled it all, and you know, have come up with a pretty interesting conclusion, right? That they think that they've got a pretty good handle on you know, how far away these particular objects are, and you know, with astronomy, you know, distance, knowing how far away something is like the most important thing, right? Because if you know how far away something is, then lots of other things sort of fall into place. And so coming up with accurate distances, or at least being confident in your distance measurements, that sets the stage for almost all the rest of astronomy, right? So really important. So very cool, very cool. And you know, the statistical uncertainties, they're saying are small, and yep, we saw that. That's not too bad. The systematic ones, though, were pretty high. But again, you know, they're saying here that they're on the order of like 5%. I don't know. Some of those numbers looked awfully big. But
Can I ask a question?
Sure.
You was on about a parsec equals, was it 2.3 light years?
I think it's 3.26 light years.
3.2. I beg your pardon.
Yeah.
Kiloparsec. I'm struggling to work that one out.
A kiloparsec is just 1,000 parsecs.
No, I knew it was 1,000th. I'm just trying to work out in real time or distance what that is.
Well, 1,000 parsecs is 3,260 light years.
Right. Okay.
Yeah. Just you just have to multiply. The astronomers try to, you know, they try to keep things simple if they can, but that doesn't always work. Red spiral galaxies. Think global, act local, right? The influence of environment, age, and host mass on type 1a supernova light curve. So type 1a supernova is when a white dwarf actually explodes. So, okay, yeah, again, you know, it's like, all right, I'm not quite sure what the excitement there is, but for some reason, you know, these authors have determined that that's an interesting topic. Yeah, I'm not following that one. Radio source extraction with profound. That must be a piece of software or something. Stars, symbiotic stars. I don't remember what symbiotic stars are. I'd have to look that one up. But again, you know, it's using, you know, these same surveys that keep popping up over and over and over again because they're great surveys. A macro image slicer, okay. 2-day rotation conversion with application to fast radio bursts. Fast radio bursts are all the excitement now. So and I'm glad, you know, these are very, very transient events, and nobody knows what they are at all. And I think that's great. I think that's awesome. Let's see. I'm not really seeing anything particularly eye-catching today. Phased array that has to do with probably radio astronomy. Yeah, they're talking about. Go ahead, Tim.
Sorry, I'm just going to pop a link in the chat. Symbiotic star.
Oh, cool. Thanks. Thanks. That's what I say. You know, I mean, there are all these jumping off points, right? It's like I have no idea what you know, I mean, I'd have to remind myself, you know, what a symbiotic star is, and you know, you can go off on that path, and it's a wonderful path, right? Dun, 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 dun. Oh wow, I don't. Yeah. Transfer oxygen. GE. That's an element of some sort, but I don't recognize that that particular element. And KR. KR, is that an element too? Wow, I don't remember.
Kryptonite.
It might be. I'm not sure. I don't remember. You know, we find the elements strewn throughout the universe. We just have to look for them. Climbing halo merger trees with tree frog. Huh. Must be some kind of computer program. Yeah. Okay. Modified dynamics. Transient gravitational wave signals associated with magnetar bursts. Global analysis and luminosity, color-dependent galaxy clustering. Some of these relationships are just really baffling, right? What does galaxy clustering have to do with the color and brightness of a galaxy? I don't know. It's a interesting relationship that they've found, I guess. Yeah. Now, I have no idea what that kind of a variable is. Is that a variable star? Could be. Huh. Lots of terminology that I've never heard of at all. I like it. In dense planetary rings. Cool. Ancient and primordial collisional family as the main sources of X-type asteroids. I don't know what an X-type asteroid is, but obviously it's a kind of asteroid. Either made up of, you know, particular kinds of things, or, you know, maybe some kind of orbit, sort of a specific orbit. Could be. So here's some DSLR data. That's kind of cool. Looking at variable stars. Kind of neat. Kind of neat. Magnetic transients in the solar active region plague, or plage, as they say. So this has to do with of course, the sun. Yeah, I'm really not seeing anything that's grabbing me too hard. A lot of stuff flying way over my head. Wow. What shapes a galaxy? Unraveling the role of mass, environment, and star formation in forming galactic structure. Wow, that is a big topic. I cannot believe that somebody would try tackling that topic. Wow, that's huge. Wow, and so they looked at 500,000 galaxies. Wow. So bulge to total stellar mass ratio. Huh. Morphological dependence on wavy rank. I'm going to zoom in a little bit here if I can. Can I? Nope, it's not letting me. Oh, I can do it this way. Okay. Actually do it here. Whoop, where'd it go? Uh-oh, I lost it. Oh, no. Huh, I totally lost where we were. I don't know how that happened. We'll find it again. Sharp edges, main belt, X-ray, lithium ISM. There it is. Distance from star-forming main sequence, following stellar mass. Wow, that's a very, very big topic. Holy moly. Yeah. Oh, I lost it again. All right. I don't know why it keeps jumping around. That might be a pretty interesting read. I might come back to that a little bit because that's that seems a little bit interesting, and I'm noticing what time it is too. So I don't want to keep anybody much longer. Cassiopeia A. That's a nice radio source for you radio folks out there. I think it's the brightest extrasolar radio source out there in the sky. Exploded star. I don't remember when that exploded. Not too long ago. I think in the history of, I mean, maybe a couple thousand years ago, a few thousand years ago. Yeah, I don't know if it's going to say or not. Should we look just really quick? We could look it up too elsewhere, but let's see if the paper just sort of briefly mentions when Cassiopeia A blew up. Crab, nebula, supernova. Cassiopeia A is a galactic supernova remnant, age approximately 330 years. Oh, okay, wow, okay. I thought that was a little bit longer ago, but apparently not. So so yeah, that star exploded just a couple of centuries ago. I don't recall if anybody ever reported seeing it. I'm sure somebody saw that. That would have been relatively bright. 3.4 kiloparsecs away, right? So we'll do the math here. So kiloparsec, of course, is 1,000 times 3.26. So 3260. Oops, 3260 times 3.4. So about 11,000 light years away. So yeah, wow, that must have been pretty bright. That must have been visible to lots and lots of people. Anyway, yeah, cool. Very cool. Latitudinal differential rotation. Oh, that thing keeps jumping around like that. It's driving me crazy. mapping the stellar age of the Milky Way bulge with the VVV. What is the VVV? It's some kind of a survey here. Okay, it's the, I guess it's the vista variables in the, oh, I'm not going to be able to read that very well. Okay. Let's keep going. Did we lose Tom?
Yeah.
Yeah, maybe he had to get out of here. Cosmic opacity. Picard. Debris of asteroid disruptions close to the sun. Kind of cool. Wow, lots of papers, lots of new papers today. Usually there's about 40 to 50 of them, so this is relatively average. Constraints on the low frequency spectrum of FRB 121102. So that's a fast radio burst object or event. Okay, cool. Helium enrichment, effects of dark matter and star formation, beryllium 7. Wow, a lot of this stuff is flying way over my head, as I said. This is yeehaw. So seasonal evolution of temperatures in Titan's lower stratosphere. So, see, I guess it looks like they got their data from Cassini. That's a good source. It's a good source for sure.
Do we keep losing you as well, Bobby?
Yeah, I'm not sure what's going on.
It's acting very weird tonight. Well,
yeah. Well, that's how it goes. That is the nature of Astronomy Daily Live. Is going a little weird. Going just a little weird all the time. So, all right, well, cool. Let's get out of here for now. That's that was a heavy list. Wow. Lots of pretty amazing things going on. Most of which wow.
Oh, you're on laptop, Tom.
Pretty good. Pretty good. All right. Well, let's get out of here for now. So I'm going to check the chat one more time. Really
Yeah,
quickly.
before technology has a cow.
Yeah.
There's that link in there, Matt, as well, to the I forgot what you called it now. The
oh, cool. This thing, the symbiotic stars.
Symbiotic star, yeah, symbiotic.
Yeah.
Star. Yeah.
Cool. I will definitely check that out to remind myself, and we should probably put that over on the Discord too. So you can do that, or I can do it a little bit later, whichever one. But yeah.
Speaking of Discord, nice job on them jigsaw patterns.
Yeah. So do you like those?
I do. I can't believe I got the frame done and then accidentally hit the back button on my bloody mouse.
Yeah. Well, I think you're right. You probably have to sign in and all that, and then
It'd probably save them.
Yeah, because it should save those. Okay. Well, I'm going to continue making those because they're easy and fun, and yeah.
I just wish they made an app for it and stuff, so I can definitely show it to like someone that would definitely love those puzzles.
I was speaking to someone. Apparently, there is an app for it, but they couldn't tell me the bloody name of it. They'd forgotten.
Okay, yeah.
I couldn't tell you what platform it's on either.
I'm going to look into that a little bit because, yeah, I mean, when I did a search for those things, I just went to the first one on the list, right? So I haven't even looked at all. But I have to imagine that there probably is an app. There probably is. So yeah, I'll look around a little bit. And Bobby, you look around too if you want. See if there's anything out there because yeah, I mean it's super easy to make them, and you know, at least that site, you know, you post it up and they do everything else. So I mean it's really easy too and kind of fun. So all right, well for now I'm going to get out of here. So thanks everybody for coming in again. Thank you, panelists. You're always great. Like I always say, you know, being on the panel, make sure you have to chime in anytime, because I'm just going to keep yakking and yakking, right? So you just have to sort of jab in there and stop me. And if you
don't mind, just one final thing.
Yeah.
You know, you said you got in touch with a puzzle maker. And you said it would be quite expensive just to break even. What sort of price were you talking? Say to sell them and make a little bit.
To break even, just to break even and sort of maintain, you know, the flow, you basically have to charge double your cost, right?
Obviously.
Yeah. And so,
Hey.
and so my cost, at least from this one place, you know, to get what look like really decent puzzles. You know, they come with the box and you know the label and your brand on the sides and you know good reproduction, and these puzzle pieces are all unique, right? I think now I'm just going to be able to quote you in dollars, right? Because that's all I know. They for 64 puzzles they want and 16-inch by 20-inch. I think close to 500 pieces. I think it was a 500 piece. They wanted $11.45 each.
Wow.
So I would have to charge, you know, like $25 each.
$25. I'd buy one.
Just well, and then you have to pay shipping, right? Which is another 15 or so. So you know, you're talking $40 for a puzzle.
35 GBP.
Yeah, and you know, I'm thinking, you know what? I'm going to throw it online, and problem solved, right? And
I mean, you're not gonna get any profit for just doing a physical puzzle?
No, none at all. No, you know, that'd be break even.
If you're, I mean, like if you're gonna be doing a physical puzzle, if like those images are open source, there's no copyright in it. At least you should get some revenue, some type of loyalty and stuff.
Well, yeah, but you know, I mean, what you have to do, right, is you can't buy 64 puzzles. You have to buy 10,000 of them, and then the price drops. Right?
Yeah, they've got to set everything up for a pretty much.
Yeah, no, you know, I actually really like the idea of doing the puzzles, you know, right on the screen, or you know, putting them on your phone. I think that is definitely the way to go. And you know, I'm doing this, you know, for fun, right? So I mean, I don't have to make anything at all. You know, if somebody wants to make a contribution, They certainly can, no problem, right? But I think that that is definitely the way to go. And with people like me who have these horrible furry creatures scurrying around everywhere, right? I don't want to have a puzzle laid out, and I'm spending hours and hours and hours doing it. They come along and whammo, right? I don't want that, right? I like it on the screen, right? Because then, yeah, exactly.
Lazy git.
Yeah, so to have that, sitting on your screen or sitting on your phone, I think that's a great way to do it. And like I said, if you want to make a contribution, make them, right? I mean, I've got a link there. So yeah. I think that's a great way to do it. And look, if you go to online puzzle places like well, any of them, right? You're going to pay $12 or $13 for a nice sized puzzle, right? With free shipping, right? I can't compete with that, right? I mean, if I have to, if somebody has to pay, 35 to 40 bucks for a puzzle, when they can get practically exactly the same thing for a third of that price, they're not going to buy mine. I mean, that doesn't make any sense, right? So I like the online thing. Anyway, all right. Well, with that, I'm going to get out of here for now, but I will definitely be back tomorrow, same time, same place, 2 hours UTC, right here on the virtual porch, right? So, all right. Well, take care, everybody. Have a great evening, a great day. Spread the word. Spread the word. The channel is slowly growing, and I think that is very, very cool because the more folks that I can share this passion with, just makes me feel better and better and better. So, all right. Take care, everybody. I will see you on the spin. See you later. Bye.